I forgot to mention that we have all the members of the jury sat here on the front row who have been listening very intently, as it's their decision, their job to decide which the jury thinks is the overall best tall building. So if there's any questions from the jury, I'm going to give them priority. But who would like to ask a question? James Perak from Toronto.
First of all, congratulations to all of you for 4 fantastic presentations. I have a couple of questions. I'll start, Kenneth, with you. I'm wondering if you can elaborate a little bit more on the sustainability aspects of One World Trade. Your brief talked about recycled steel, recycled concrete, and responsibly harvested wood in construction.
So let's talk about it a little bit. 7 World Trade Center was a model of LEED Gold version 1. The energy requirements were kind of light. I don't even think the building would meet certified today. And so we were challenging ourselves with the building. I think you know the initial design had wind turbines in it as a part of the design. So when we were forced to redesign it, we looked at a number of techniques to modify that. So we brought in fuel cells into the lower levels of the building, which I didn't mention. Unfortunately, those were destroyed by Hurricane Sandy. They were located in the lower portion of the building, and we're in the midst of redesigning the next generation of fuel cells. Fuel cells is designed and built in New York. The use of fly ash in the concrete, I'm sure Yoram could go into, was a large part of our effort, and also was at the beginning of that effort was to use less formwork, and when we use formwork, to use certified forest woods throughout the building. It seems it's totally common now. It's what we're doing throughout our industry. But at the time, the contractors sort of didn't know that they could source that amount of wood in the project where we were using wood. We limited it. The other thing I didn't mention was that the building is part of the World Trade Center, and the World Trade Center has its own guidelines. And we proposed an idea, the design team proposed the idea of exemplar spaces. Exemplar spaces are areas of the building, approximately 5,000 square feet, where you would demonstrate to the tenants and the potential tenants for the building how you would fit out a space in a modern way. And the technologies we were talking about, this is again 2004, 2005, were LED light systems, underfloor cooling systems, chilled beam in the ceiling. We were asking outside suppliers, CASE, our collaboration with RPI, to come to the table with technologies and to show them and to bring in people to demonstrate those systems. The other part of it is the renewable energy, which I mentioned. The building is entirely using renewable energy, and ultimately is going to be making carbon, has looked at the carbon issue from the steel and the need to maximize the amount of recycled steel in the building. And we work with ArcelorMittal, who was the fabricator, or the steel supplier. Yep, the steel supplier for the building, and we had great conversations with them about how to maximize those elements. I'm sorry to run on, because it really was a great deal for us. This was a challenge in a New York market which hadn't seen the green building. They didn't know what it meant. They had been told by others that it had no value to the rentable area. But we knew through our international practice, and all of the architects know this from their international practice, that corporations and owners were initiating standards, that companies couldn't be in an unsustainable building, that there had to be a responsible practice for both the energy component, but also the lives of the people in the building. And that's where we focused on the glass and making it as transparent as possible to maximize daylight in the building.
Thank you. One more. A question for Mr. Shinichi about your project, the wind funnel on top. I'm wondering if you could talk a little bit about your vision for that, and also, is it achieving the desired effects that you would hope for?
I think typically vertical shelf space uses for chimney effect, where the hot air rises and the products produces air movement to above. However, our curveball system with flower funnel is it's inspired instead by the traditional wind catcher used in the Middle East area, capturing the fresh and cool air on roofs, supplying cool breeze to lower floors. In this case, air is driven by pressure produced by the wind. So our Capital Green project is we wanted to make architecture like a living plant that breathes, not like only forms or a shape is organic. We wanted to make architecture like living organism. It means the building is breathing like a tree. So the flower has two shapes, and the big shape flower get the continuous wind in Singapore, and the air pressure makes how to say invite the air from the sky forest. Lower air catcher catch the air in the sky forest by the pressure from the big flower. And the cool boy system also works well because in Singapore, the air condition is always cooling. So the air shaft of a cool boy, it's made by concrete, keeps the cool condition to makes the air temperature lower. So temperature difference between the ground level to 200 meters above, it's about 2 degree difference. But after passing the cool void, the air to the ground level is it makes a 5 degree 5 degree temperature difference. So that can helps for our air handling unit to saving the energy. Is that right? Okay.
Okay, thank you. Next question. Question here in the middle.
Hi, my name is Eilon Shen from Taiwan, BESCPC Group. And my question is to Stefano Boeri. And we're also the finalists for Innovation Awards. We have really similar design for the vertical forest building, but twisted. And what is challenging you have been through while you're planting the trees on the vertical forest buildings? And secondly, what is the incentive from the government that encourage developers or architects to create such green buildings in your country or as far as you know? Thank you.
Thanks. The second answer is no. At the moment, we have not incentivized. So it's what we have done in Milano. It's a really prototype. But for sure, I think that the success of this prototype will move and change a little bit not only let me say the knowledge and the awareness in the political milieu about the necessity to let me say facilitate the replicas of such a settlement. About the first, as I was trying to show, there are a lot of technical troubles, but for the first time we were asked to deal and to overcome. And probably the most important was about wind, because as you can imagine, trees which are 10, 12 meters high at 100, 120 meters tall, it means that you are exposed to different and in some cases also extreme windy conditions. So the point that we have studied together with ARUP was how to, for instance, imagine to fix the roots of the plants at the interior of the basement of the pots. And that was one, and at the same time we were working with engineers that are, let me, expert in the study of the reaction of trees to wind this condition. So, for instance, we have also, in the selection of the trees, we're considering the fact that some trees, and this is not related to the dimension of the branch, but sometimes there are, because they are so huge and extended the branch, they are more capable to be flexible also in relation to extreme windy conditions. So it was very important also the kind of selection of trees that we did thanks to the botanists that were working with us. So it was really an interdisciplinary work and was very important for all of us. Thank you so much.
Okay, a question on the front row from Yoram member Carl Fender from Melbourne, Australia.
Thanks, Anthony. Also for Stefano, Bosco Verticale. The initiatives in the sky are fantastic. But could you talk a little bit about how the building engages with the ground plane, the public realm?
Well, the building, the two buildings are by a park. So when we started to think the opportunity to realize buildings in Portanova, in the Portanova district, we knew that there was this huge public park. And it is under construction, the park. It's designed by inside, outside. And I'm sure that the idea to have a kind of vertical ecosystem which is connected on the ground with such a public environment, green environment, it's significant in a way. So it's in a certain way, I think when we talk about biodiversity, we have always to take care of how we can create some corridors also inside the city that make the possibility for some other species to move and to find a habitat also inside a super dense urban habitat like is the center of Milano. Thanks.
Okay, more questions? Question up at the top, is there?
Hello. I'm a grad student in IIT. My question is on Verticale Bosco of Milan. And it's my simple question, what happened to the plants on the northern side of the facade, especially in the winter, like when sunlight is not there?
That's a very good question. For instance, the selection of these more than 100 pieces of trees was also related to the fact that in the northern facade, we were basically selecting trees that are losing the leaves in winter time, just to help the sunlight to enter. So the four different facades were very important in the selection of the different trees, of the different plants, and the relation between the interior and the sunlight was let me say, a constraint for us.
Question here.
So on the southern facade, we are more Mediterranean plants, so we're capable to absorb and create sun.
Hi, my name is Maria Warren. I'm a civil engineering student at IIT, and I just had a question about One World Trade Center. I was wondering if there was anything that was done structurally differently to the building than you normally do, besides the different staircase arrangement, keeping in mind past terrorism in the area.
Yeah. Great question. As I started my presentation, there is limited information we can share, but certainly there was. First of all, if you look at the core, the core is housing the mechanical systems. There are many aspects of the design incorporating the protection that was required. We did not define what the threat was, but we had to address the threats through the structure. What we were trying to do was to build a conventional structure that looks almost as any other office building, but doing much more. And that was for a few reasons. One, visibility. We didn't want to expose the design. And the other one, the price. We didn't want to drive the price up and create some kind of esoteric design that would draw the cost to increase. So yes, there's a lot of defense mechanism built into the structure. A lot of the connections, if you saw the presentation, we couldn't focus on structural elements because we were requested not to expose them, but a lot of the members and the connections were designed to address these threats. The curtain wall was also designed for that threat. And perhaps you can elaborate how this threat was defined and addressed through different trades.
So throughout the building, the threats were identified with a wonderful security team that would ask questions, and we were part of a research with the University of Illinois, Champaign-Urbana. So I'll kind of just go through some of them. The curtain wall is a 3-layer curtain wall. It has a laminated glass on the inside that is made of ultra-low iron glass. So despite the thickness of this glass, it's completely transparent. The coatings that we used on the outside, which obviously with the energy code changing had to become more reflective, yet we challenged the folks that make these coatings, these low emissivity coatings, to maximize visibility from the inside. The mullions are reinforced with steel in locations. The connections to the slab edge are made of stainless steel, not just because of the robustness of the stainless steel, but because of the durability of the steel over time through rust and other things that might happen to the system. We went through numerous tests, some of them quite wonderful, where we were testing the low iron glass and going out to the market and having people come in, but we also did a blast test in New Mexico wherein only 2 outer lights were damaged. I can't talk about what the load was, but it was only 2 outer lights, but the entire wall was compressed 3.5 inches and stayed in place. So it's tested over and over. The systems are robust, redundant, and had goals of protecting people in the lobby in a way that we hadn't thought about before, using structure, the wall that you see, but allowing penetrations above their heads by providing the high-strength concrete that would be robust, and by looking at the site and creating distance between the building and the edge of the road, 100-foot set-off distance, without it being obvious when you come to the site.
I just wanted to add the structure is designed for multi-level of redundancy, and also talking about the concrete. This is the first time that 14,000 PSI concrete was introduced in New York. That was a huge challenge, combining that with the fact we had mass concrete. Going back to the lead question, the steel had over 90% of recycled material by requirement, but in fact it was over 99%. The concrete, the cement was replaced between 60 and 70% by fly ash and slag, which also helped reduce the heat of hydration in the mass concretes, the walls affected by the mass concrete. I must say that the advanced concrete we introduced on this project really changed the whole industry, or the whole concrete supply chain in New York City. It made the concrete, actually through this research, much more economical, and brought us to new levels of economy. It basically made the concrete much more competitive.
Question here?
Hello. Hey, my name is Andrew. I'm from Kansas State University. I'd like to extend Mr. Fender's question to everybody else about how your buildings and design meet the street, because it is about urban habitat and it's largely defined by the street experience. And also I had a second question. I attended Mr. Boeri's lecture yesterday, and you talked about anticipating the future. So I was wondering how everyone else is anticipating the future in their designs.
Okay, perhaps we can take those questions both together. The questions are urban habitat at the ground, how does the tower meet the ground? And how does your building or anticipate the future? Why don't we start with Toby and Bob with that one?
Sure. I think for us, how tall towers hit the ground has always been a very important consideration. There's a massive structure coming down to the ground to where people are. So in each, every project where we get involved in that, we do think very carefully and seriously about that interaction. On this project, it really was a case of trying to integrate the tower with the retail elements. The scale of the retail elements was something we also considered very carefully, so that the height of the blocks towards the pedestrian areas were much lower, and they stacked up higher as they moved away from those areas. And where the towers come in, again, it's bringing those structures into that, integrating that into the grid.
Anticipating the future, Toby. How does your tower anticipate the future? Not a tough question.
Not a tough question. I think, in many ways it goes to a sustainable story about how, in
in many ways, we've tried to establish a sort of, if you like, almost a passive approach to sustainability. You know, the idea of creating openings into retail spaces, things that haven't been done before. Passively, the towers, the form and shape of the towers try and respond to the very aggressive climate that is in Abu Dhabi, and hopefully sets a benchmark, a new benchmark for other developments. And I know that Alida are very committed to, with their projects, to meeting the highest sustainability ratings. So I think it's all projects that look to the future is really how we address use of energy, future energy, and how buildings, architects have a responsibility to make sure their buildings address the future in that respect.
Stefano, you already answered the question about the urban habitat. How about the future?
Well, I think that we have to take care of an ethic of research also inside our discipline, and that means that when we produce an experiment like we have done, or many of the time, we have to, let me say, in a way also allow the public and the users to falsificate and criticize what you're doing. So we started, and thanks also to your help, with the idea that we have to make public all the different steps of our research. So all what we have done in order to anticipate the future in terms of technology, in terms of, let me say, technical solutions are public, and now can be used by other architects, by other engineers, by other companies to try to improve what we have done. And also thanks to this, and thanks to this award, that we are now going in Paris for the Forum of the United Nations to talk about how architecture can contribute seriously to the fight against climate change.
Shinichi, do you want to comment on that?
Mr. Hinkon will answer about this question.
The two parts, one is how the tower meets the ground. I think in my presentation I did, first of all, our project is a fairly small project. The site is only about 5,400 square meters. It's basically a tower that sits on the ground. I think the few things that we've done on the ground is to create a covered plaza. In a place like Singapore, it's quite important because there's always rain at any time that's possible, and the sun. So, and thanks to the in fact, the authorities, there's always a requirement to create a lot of shaded covered walkways and all that. So, besides providing all these public weather-protected paths across the site, we also created some public space with public art. I think in a way, we feel that it was important that the building makes a presence on the ground and not just in the sky. And I think it's quite successful, as you can see some of the pictures of the covered plaza. It's surrounded very densely by buildings, and right now it becomes a very recognizable space. And I think in that sense, it's also a very popular space for people just to take a break and rest. So I think that's how we try to engage the ground. Really, the building has nothing on the ground except lobbies and circulation area with a few cafes. In terms of anticipating the future, I think we can only expect the future to be denser, to be more built up, to be more critical in terms of environmental sustainability. So I think in our building, we've tried to address this by a few ways. I think the building is called Capital Green for various reasons. Green really in terms of environmental sustainability. The fact that we have ledges all around the building, a kind of permeable facade, is quite unusual in a kind of office building in a part of the world where people try to build glass boxes. So having this passive shading does help a lot with making the building quite energy efficient. It's also green in terms of having greenery, and as I've mentioned, we try to give a respite with greenery amidst a city that's really going to be denser and denser, and less and more concrete and built up steel and glass. So we try to provide a difference on that. And the third part, of course, is also the connectivity with nature by having views and enjoyment of possibility of enjoying the sky terraces, the sky forests in the middle of the city. I hope that answers the question.
Thank you. Ken, do you want a final word on this?
Yeah, I'm thinking of the other projects which are just also fantastic, that they're actually about the ground meeting the sky in many ways, that the ground comes up through the building. And One World Trade Center is a building that must land on the ground, as many iconic buildings need to. These forms, these solids that we see need to come down and clearly hit the ground. We didn't have the ability to penetrate the surface for obvious reasons, and that those moments that the building need to be in scale with the building, and so it has a very heroic quality as it hits the ground. What I didn't talk about was, in fact, how the life of the building goes out into the grounds. There's about almost an acre park on both sides of the building split, one for the entrance to the observation deck where people can gather. We saw the building as having multiple lives, and one to the east, which won't open for a few years until the Performing Arts Center, which is a place for the workers and the tenants of the building to gather and for them to take advantage of this amazing Performing Arts Center that's going to come to the east of us. But most importantly, it sits in that garden, that beautiful park that Peter Walker designed that will ultimately, and it goes to the second question, will become a large public park, not just a memorial park, but a park like the garden, Grand Army Plaza, the grounds in Brooklyn, the park in Boston that were memorial grounds that ultimately became great public parks. The other part of meeting the ground is just something that we're dealing with, which is the birds. And we work with an ornithologist to have a conversation. If you're aware of it, people would go out there and find many birds who had died during migration. And we had a very fascinating conversation, and the sort of breakup of the facade on the lower portion of the building is to provide a scattered surface where there's limited consistent reflectivity, because birds don't understand glass. They see the trees that are reflected and they go to those trees, and that's where a lot of bird death happens. So we created a surface made of fritted glass, and to reduce those reflections and try and reduce that, as well as by turning lights and limiting the lighting in the building. Our futurist has come, our tenant has arrived, and it wasn't the tenant we thought, so we provided a maximum flexibility in terms of a column-free space, and also to minimize openings in the core wall, so that what we saw through our interiors practice was the way work was going to change, both through densification, but also through the elimination of the closed office, or the relocation of the closed office to the cores, an open collaborative space that surrounded the core continuously, and a space where daylight was maximized for flexibility. It's, the future comes much quicker than you anticipate, and it isn't anything that you see. So you provide additional flexibility where you can, and you provide larger spaces in the core that are collaborative zones where people can meet and innovate.